Good morning students, welcome to my channel Chemical Crystal Palace. Today in the first class I am going to discuss about the study of gas laws. First of all, we should know what are gases. Gases are those phase of matter in which the intermolecular force of attraction is negligible and they move about freely in any direction. Like every substance has some characteristic properties, so thus our gases also have some characteristic properties. So the characteristic properties of gases can be stated as follows. Number one, they have no definite shape and volume. This means that we know that the molecules in gases are very much far apart from each other. That is, the intermolecular force of attraction in them is very small, as a result of which the molecules in the gases are in random motion and they occupy the volume of the container in which they are contained, and they do not have any specific shape and volume. The second characteristic property is high compressibility of gases. The second property of gases is that they have high compressibility. The volume of the gas can be easily compressed to a much smaller volume by increasing the pressure upon it. The third property which they show is they exert pressure in all directions. Unlike solids and liquids which exert pressure downwards, gases exert pressure in all directions uniformly. That is, they will exert equal pressure on the walls of the container. The fourth property is they have very low density. The number of molecules per unit volume of a gas is much lower compared to that of a liquid and solid, as a result of which the density of the gases is very low. Number 5 property is diffusibility. Two gases or more than that can mix together very randomly and form a homogeneous mixture. Homogeneous mixture. That is, if we mix A gas plus a B gas plus C gas, they will form a homogeneous mixture. What does the word homogeneous mixture mean? It means that in the container or in the room, the amount of A, B and C gases will be equally spread. The sixth property is the average kinetic energy of a molecule is directly proportional to its absolute temperature. Next, we will discuss about gas laws. So, gas laws. What are gas laws? These are certain rules which a gas follows when subjected to a change in temperature, pressure and volume. we have to keep in mind three parameters, that is temperature, pressure and the volume of the gas needs to be required in order to maintain the gas laws. So first we need to know what is volume of a gas. The volume of a gas can be defined as the space occupied by the fixed mass of a gas is called the volume of the gas. The units of volume is suggested to be liter, decameter cube, centimeter cube, milliliter, etc. and meter cube also, in which the SI unit is meter cube. Now, some of the relations between the units of volume are 1 liter is equals to 1 decameter cube, which is again equals to 1000 cc or centimeter cube, which is equal to 1000 ml. Or we can say that 1 centimeter cube is equals to 1 ml. Next parameter is pressure. In physics, we define pressure as the force applied per unit area. And now with this definition, we add force applied per unit area on the walls of the container. Again, there are some units of pressure. Units of pressure are atm or atmosphere, Pascal, which is the SI unit of pressure, and next is torsilli or torr. The relationships between these units of pressure are 1 atm equals to 76 centimeter of mercury, or 1 atm equals to 101.325 kilopascal, or 1.01 into 10 to the power 5 Pascal. Keep in mind this is kilopascal and this is Pascal. The next one which we can write is 1 millimeter of mercury equals to 1 torr. The third parameter which we will discuss about is the temperature. We know that the temperature can be defined as the degree of hotness or coldness of a body. The average kinetic energy possessed by a molecule of a gas is its temperature, as I have already mentioned above. So the units of temperature are degree Celsius, degree Fahrenheit and Kelvin. Keep in mind we use degree with Celsius and Fahrenheit and not with Kelvin. The relationships between the units of temperature are Kelvin equals to degree Celsius plus 273, or Fahrenheit minus 32 by 100 equals to Celsius by 100 equals to Kelvin minus 273 by 100. Or the most important conversions which are to be kept in mind, the formulas are Fahrenheit equals to 9 by 5, centigrade plus 32, or centigrade equals to 5 by 9, Fahrenheit minus 32. Other than these three parameters, that is the temperature, pressure and the volume, there is yet another parameter which we should know about is the mass. Mass can be defined as, here in case of gases, the amount of matter contained is called the mass. The unit of mass is given by kg or gram. Kg is the SI unit. 1 kg equals to 1000 gram. In case of gases, the idea of number of moles come into play. Now, number of moles can be defined as the given mass of the gas by molar mass of the gas. This idea of moles will be studied in higher class in the chapter of mole concept or stoichiometry. In the example of the number of moles, we can state that the given mass of a nitrogen gas is 28 grams and we need to find out its molar mass. We know that molar weight of one atom of nitrogen is 14 grams. So there are 2 atoms of nitrogen. It will be 2 into 14, 28 grams. So the number of moles of nitrogen here in this question is given mass of nitrogen is 28. By the molar mass found out of nitrogen gas is 28. So the number of moles here is 1. Now we enter into the main topic of gas laws. Basically, there are 2 gas laws which we need to follow. The first is the Boyle's law. A scientist named Boyle noticed that when the temperature of a gas is remain constant, the volume of the given mass of a dry gas is inversely proportional to its pressure. What does that statement mean? It means that if we take a container in which a certain amount of gas is present and a piston is set on top of it and we apply pressure in the downwards direction. So as we increase the pressure and the piston goes down, then the volume of the gas in the container is compressed as the pressure increases, the volume of the gas decreases. This is what Boyle's law states. Boyle's law states that when the temperature is kept constant, the volume of a given mass of dry gas is inversely proportional to its pressure. Now the mathematical expression of Boyle's law can be given as the volume is denoted by V is inversely proportional to its pressure, which is denoted by P. In the condition that the temperature and the mass of the gas is kept constant, or V is equals to K by P. Here the proportionality sign is removed by using a proportionality constant, which we denote by K, or PV equals to K, which is constant. When we have to discuss problems based on Boyle's law, it will be given about 2 or more gases. What will be the formula at that time? P1 V1 equals to P2 V2. What does P1 V1 and P2 V2 denote? It denotes that the pressure of a gas A at P1 and volume of the gas A at V1, and P2 denotes the pressure of the gas B at P2 with volume at V2. We will discuss about the graphical representation of Boyle's law. We have learned before that the mathematical representation of Boyle's law is given by PV equals to constant. Whenever pressure is plotted against volume by keeping the temperature constant, we get a curve which is said to be a hyperbola. And always remember that when the temperature is kept constant, such a graph is called an isotherm. What does this mean? Iso means same and therm means temperature. Coming on to the experimental data to illustrate Boyle's law, the experiment is performed in 3 phases, 1, 2 and 3. In the first phase, the pressure applied is 2 atm and the volume is 1000 ml. Then by applying Boyle's law, PV, we get 2000. In the second phase, the pressure applied is 4 atm and the volume taken is 500 ml, and again PV is constant, that is 2000. Again in the third phase, the pressure applied is 8 atm and the volume is 250 ml, and by Boyle's law we find that PV is again 2000. So we can see that as the pressure is increasing consecutively, that is 2, 4, 8, means the pressure is doubling, the volume is getting reduced by half, that is 1500 and 250. Now the second gas law which we will discuss is Charles' law. Another scientist named Charles discovered that when the pressure of a gas was held constant, the volume of a given mass of a dry gas is directly proportional to its absolute temperature. It means that when the pressure was kept constant, that time the volume of a given mass of a dry gas is directly proportional to its absolute temperature. Now coming up to Charles' observation, this is very important. It states that at constant pressure, the volume of a given mass of a dry gas increases or decreases by 1 by 273 of its original volume at 0 degrees Celsius for each degree Celsius rise or fall in temperature. What does this entire thing mean? It means that whenever we keep the pressure of a given mass of a gas constant, the volume will increase or decrease by the factor 1 by 273 of its original volume. Say that the original volume to be V, then each time it will increase by V by 273 or decrease by V by 273 at 0 degrees Celsius for each degree Celsius rise or fall in temperature. The mathematical expression of Charles' law is as follows. Volume is directly proportional to the absolute temperature at constant pressure. The proportionality sign is removed by using the proportionality constant K, or V by T equals to K. Now, when two gases are given, that time the formula is converted to V1 by T1 is equals to V2 by T2 equals to K. That is the constant. Like the Boyle's law, there is also a graphical representation of the Charles' law. We know that by Charles' law, V by T equals to K. That is, whenever volume is plotted against temperature, by keeping pressure constant, we get a linear curve. Always remember that whenever a graph is plotted with keeping pressure constant, such a graph is called an isobar. What does it mean? Iso means same and bar means pressure. A short note on STP. The volumes of gases change with temperature and pressure. Hence, a standard value of temperature and pressure is chosen to which gas volumes are referred. This standard temperature is given to be 0 degrees Celsius or 273 Kelvin, and the standard pressure is maintained at 76 centimeter of mercury or 1 atm pressure.